we are turning our source code into this binary code. But really, before we actually reach that binary, we have to hit a number. And each of these data types, the primitive ones, are using numbers to represent characters, shorts, etc., different types of data. And based on how many bits that each of these data types gets will determine the range of possibilities of numbers that that data type can have. And that's why we see that our longs are going to have 32 or 64 bits. And it even allows us to start to see how we can differ between systems and how 32-bit systems versus 64-bit systems will take different amount of bits or rather bytes for their longs, with our 64-bit system taking 8 bytes. Now, our 32-bit system can still do these longs, but instead of processing them all at once for the data type, it's going to process a long and another long essentially linked to it, whereas we're going to actually get these full 8 bytes for our system. We start to see how we might be able to represent basic decimal numbers in terms of 1 byte as the smallest standard unit. We can even see how our second bit here is representing the sign. So whenever it's 1, it's going to be a negative number, 0 is not. And we should also keep in mind we have to also include 0 as a number itself. We then see how this first bit is going to allow us to create much larger numbers because it essentially links our different bytes together. And for the numbers themselves, it's rather usually in hexadecimal in terms of the 6 bits that follow those first 2. Here's some more detail. We then can go back to this slide about the representations to memory. And what this is it's part of our compiler. It's really almost a compiler within a compiler that really does the work. We're having different languages like ASCII, UTF-8, etc., or rather representations. And these are saying what each character, long, float, etc. is in terms of binary. It's essentially a dictionary that starts to set some very initial rules for how it works. And it even brings up quantum computing